Hello, pre-calc students, and welcome back. Today we are continuing our work with section 5.2. We're going to start talking about the sum and difference formulas for tangent. So again, make sure you have your unit circle up because we'll be referring to that throughout the lesson. Tangent sum and difference formulas. So if you need to do tangent of the sum of two angles, here I've got alpha plus beta, you can do the following. Tangent of alpha plus tangent beta, all divided by 1 minus tangent of alpha times tangent beta. And then for tangent of alpha minus beta, again, it's a very similar setup, but just with the opposite signs. So that plus becomes a minus, and that minus becomes a plus. So go ahead and get these in your notes, and then let's go on to our first example. So the use this has is I can do problems that would have been impossible before. Find the exact value of tangent of 105 degrees. Now 105 was not one of the angles on our unit circle. However, I can create this angle 105 using angles on the unit circle. So just find two angles that either add up or subtract to give you 105. Again, there's a lot of options, but I'm going to choose to use 45 degrees and 60 degrees. So if I sum those two, I get 105. Then I'm going to use this identity here for the sum of these two angles. So I'm imagining 105 degrees as 60 plus 45, and then I use my identity of tangent of alpha plus beta, and that would be tangent alpha plus tangent beta divided by 1 minus tan alpha times tan beta. And you can see all my alphas I replaced with 60s, and my betas I replaced with 45s. Now what I need to do is all these tan 60s and tan 45s, I know those values from the unit circle. So if you've got your tangent values memorized, I'm going to replace tangent 60 with square root of 3. And I'll replace tangent 45 with a 1. So when I do that, I get the following. On the top, tan 60 becomes square root 3, and then tan 45 becomes a 1. And then on the bottom, that is a 1 minus tan 60 times tan 45, so that becomes 1 minus square root 3 times 1. Then the next thing I need to do is multiply there on the bottom, and I get the following. But you'll notice I've got a square root on the bottom of my fraction, which is not allowed. And if you remember back to our algebra review at the beginning of this chapter, we said to deal with that, you need to multiply by the conjugate of this binomial. So the conjugate of 1 minus the square root of 3 is 1 plus the square root of 3. So I multiply the top and bottom by 1 plus the square root of 3. Then, when I FOIL, I get that on top. When I FOIL on the bottom, I get that. Those two add up to 0. So on the bottom, I get 1 minus 3, which is negative 2. On the top, I get 1 plus 3 is 4, and then square root 3 plus square root 3 is 2 square root 3. And then I've got one more step, I've got one more step. Basically, I just divide the top by negative 2, which involves just dividing both things on top by negative 2. 4 divided by negative 2 is negative 2. And then here, this 2 root 3 divided by negative 2, I can just do 2 over 2 is 1, and then make it negative because I'm dividing by a negative, and I get minus square root 3. Let's try another one here. Let's find the exact value of 15 degrees. Now, to do this one, I identify two angles that have a sum or difference of 15 from the unit circle, and that my choice is going to be 45 and 30. So I can think of 15 degrees. When I do tangent of 15 degrees, I can rewrite that as tangent of 45 degrees minus 30 degrees. Then, there's a lot of stuff here. Let's go one step at a time. Then I use my identity, and I replace alpha with 45 and beta with 30, so I get tangent 45 degrees minus tangent 30 degrees, all divided by 1 plus tangent 45 degrees times tangent 30 degrees. I then look up tangent of 30 degrees and tangent of 45 degrees in the unit circle. Tan 45 is 1. Tan 30 degrees is square root 3 over 3. And then here I've got 1 plus, and then tan 45 is a 1. And tan 30 degrees is square root 3 over 3. My next step is to multiply there to get this fraction. But now you'll notice I actually have a new issue this time that I didn't have last time, and that is that I have fractions inside a big fraction. So what I'm doing right here is I'm multiplying through by the common denominator of 3 to get rid of my fractions inside this big fraction. So I multiply everything on the top by 3, and I multiply everything on the bottom by 3. When I do that, I get the following. 3 minus square root 3 over 3 plus square root 3. And now I've got the same issue I had last time. I'm going to multiply the top and bottom by the conjugate of the bottom. And on top here I FOIL, and on bottom I FOIL. And when I do that, I get the following. 3 times 3 gives me 9, 3 times that is there, that times 3 is there, and then that times that. So be careful with this last term here. This is negative square root 3 times negative square root 3. And negative times a negative is positive. Square root 3 times square root 3 is 3. I do a similar thing on the bottom to get the following. Those two middle terms there add up to 0. And then when I simplify, combine like terms, 9 plus 3 is 12. And that minus that is 6 root 3. And then on the bottom, those add up to 0. 9 minus 3 is 6. And for a final step, basically I just imagine that divided by 6 and that divided by 6, which you can imagine like that if that's more helpful. And 12 over 6 is 2, and 6 over 6 is 1. So there I get the following. And then finally for our last example here, this problem looks very similar to the one we did yesterday, and in fact it is the exact same. We've got this piece of information here that says suppose sine alpha is 12/13 for quadrant 2 angle alpha. That same information could be written this way. Sine alpha is 12/13 and pi over 2 is less than alpha is less than pi. This part tells you that it's in quadrant 2. And then we also have information about angle beta. The sine of angle beta is 3/5 for quadrant 1 angle beta, and then written the same way we could also have sine of angle beta is equal to 3/5 and 0 is less than beta is less than pi over 2. But now the difference is this time we're going to find the exact value of tan of alpha plus beta. Yesterday we found the exact values of sine of alpha plus beta and cosine alpha plus beta. This time we're going to look for tan. And basically what I'm going to do is use this identity for tangent of alpha plus beta. That's tan alpha plus tan beta all divided by 1 minus tan alpha times tan beta. So unfortunately, I've got 4 different trig functions there. Well, it's really the same thing twice, tan alpha there, and then tan beta there twice. I'm not told either one of those. I know what sine alpha is, and I know what sine beta is. I do not know what tangent of alpha is. So just like yesterday, what I'm going to do is I'm going to draw what I know about angle alpha, and you'll notice this is the exact same thing we did yesterday. That's what I know about angle alpha, so I draw a picture of angle alpha, and then use the Pythagorean theorem to find that missing side. It's negative for x because it's in quadrant 2, and then I'll identify the value of tangent alpha, which is y over x, 12 over negative 5. Then I need to do the same thing for angle beta. I know that angle beta is in quadrant 2 and sine of angle beta is 3/5, so I draw what I know in it's a quadrant 1 angle. Draw what I know in quadrant 1. There's y, there's r. I use the Pythagorean theorem to solve for x. X is 4. And then I identify that tangent of beta is y over x. So tan beta is 3/4. So then basically now I know that tan beta is 3/4 and tan alpha is negative 12 over 5. So I can plug those two fractions in there, and there. And when I do that, I get the following. And now, believe it or not, you can type all that into your calculator at once. Just be careful when you're typing it in. I would recommend doing it all at once, but putting an extra set of parentheses there around the numerator and then an extra set of parentheses around the denominator when you type that all in. And when you type it all in, it looks something like that. Press enter, you get a decimal. Use MathFrac to change back into fraction, and that is negative 33 over 56. So there's your answer. You can find the homework for this lesson online, and it is due tomorrow. Please email me with questions.